this is Ms. DB, and in this video we are going to go over how to do some selected problems from Chapter 5, Section 1 on quadratic functions. Now this is a very important section because you're going to be learning some of the words that we use to talk about quadratic functions, and you will also be learning what they look like and how to graph them. And also, we are going to be transforming these. We've talked about transformations previously in this class in quarter 1. The words reflection, translation, stretches, those all should be familiar to you. You will be describing these graphs using those words. All right, so on the worksheet at the beginning, it's a review of what a linear parent function looks like and then what a quadratic parent function looks like. There's a table of values and a graph, and you can see that they're very different. Quadratics are curved. They will either open upwards or downwards, and we'll look more at that as we move on. So we call the quadratic function, we call the graph of that a parabola. So the graph of a quadratic function is a parabola. And it's kind of a U-shaped, but it will get wider as it increases upwards or downward. Sometimes it's an upside down U if it's a opening downward. You can graph a quadratic function using a table. This isn't the most effective method, but it is a way you can do it if you've forgotten all other ways. You can just pick some values for x, plug them into the equation, and then graph the points that result. Remember that it'll be a nice smooth curve, so you don't connect these with straight line segments. It has to be curved. You also want to make sure that you have picked points varied enough so that you will have some on both sides of the curve, which can be tricky to do if you don't know where the vertex is. All right, so there's, like I said, that's not the best way to do it. Here's a better way. If you have your quadratic written in vertex form, then you can find out a lot of information about it. A parabola will either have a minimum or a maximum. It has a vertex, which is either the highest or lowest point. That's the turning point. For example, the parent function of f of x equals x squared has its vertex at 0, 0. You can see that right here. It will go from decreasing to increasing right at 0, 0. Note that a vertex has an x and a y coordinate. You have to list both of those if asked for a vertex. You can't just give one number as an answer. If you write the quadratic in vertex form, then you can find out lots of information. You can tell whether it's going to open downward or upward. You can tell which means it's been reflected. If it opens downward, it's been reflected about the x-axis. You can also tell if this a is not 1, then you can tell if there's been a vertical stretch or compression. If you write it as x minus a number, h is the x-coordinate of the vertex, and k, after you write the squared part, that part at the end, is the y-coordinate of the vertex. Also, the h tells you how it has been horizontally translated. So if it's a positive number, then it's moved to the right. If h is a negative number, it has been translated to the left. And k, if it's a positive number, it's been translated up. And if it's a negative number, it's been translated down. So all kinds of information can be found if you just write it in vertex form first. Here is some horizontal and vertical translations. You can look in this chart to see how those would look. And here's some examples about translating quadratic functions. So you can see that both the h and the k change, and then you can tell how it's been translated. You can also tell the vertex from this. All right, let's look at some examples. So the first question is f of x equals x squared. Well, that is the parent function. We can write that in vertex form. The a will be positive 1 because there is no number in front of the x squared, so we can put a 1 there. It's just x squared, so it must be x minus 0 plus 0. So we can tell from this that h is 0, and k, right over here, this is the k, is also 0. So the vertex is just 0, 0. We can also tell this from this graph. Here's y equals x squared right here. The vertex is at 0, 0. We can see that this opens upward. So for this, you would write upward. Now name two other points on the graph. Let's let x equal 2. If I plug 2 in right here, what does y equal? It equals 4. You can also find that by plugging 2 in here and squaring it, and you will get 4. So one of the other points on the graph would be the point 2, 4. Now you need to find one other point on the graph. Maybe look at x equals negative 2. Remember, the graph I'm looking at is the blue one here, the parent function. I'm ignoring that red. So at negative 2, what is y equal to? That would be another point on the graph. Or if you plug negative 2 in for x, what is negative 2 squared? Well, negative 2 times negative 2 is also a positive 4, so that would be another point. Now here's the last question. How has the function been transformed from the parent function? Usually when we answer this question, we'll use the words translation or reflection or stretch or compression, but in this one, we would say that there is no transformation because it is the parent function. F of x equals x squared is the parent function. The rest of these, though, there will be a transformation. Let's move down to number 3. Number 3 is f of x equals x minus 2 squared. And I want to first write this in vertex form so that I can find out some more information. Well, really, this is pretty much in vertex form. It's supposed to be x minus h squared plus k. All I have to do on this one is add the plus k. If there is no number added to the end, then this must be a 0. So h is going to be 2. Because it was not negative 2, it's supposed to be x minus h, and that's what I have. And k is going to be 0. Well, the vertex is h comma k, so this is going to be 2, 0. You can tell if it opens upward or downward by the a, the number in front of the x squared term. And that's a 1. It's a positive 1, so that means that it'll open upward. And now I have to name 2 other points on the graph. We could graph this and look at the points, or we can pick some values for x and y. Let's see what we would get when x equals 1. When x equals 1, I would have, oops, I'm going to put a 1 in here. I would have 1 minus 2 squared. So that means I would have 1 minus 2 is negative 1 squared, but negative 1 squared is equal to 1. So when x equals 1, y also equals 1. And now we need to find another point. Let's use x equals negative 1. So I want to find what is f of x when x equals negative 1. So I'm going to replace x with negative 1. And then I would get, let's see, I have to take negative 1 minus 2. That's negative 3. And then I need to square that. So if I square negative 3, I get a positive 9. So another point on my graph would be negative 1, 9. Now the last question says, how has the function been transformed from the parent function? So the transformation we can tell from our vertex form. The only thing that was changed from f of x equals x squared was that we have x minus 2. So let's look back at what this tells us. If h is not a 0, then h indicates a horizontal translation. So that means it's moved left or right. Because our h is positive, that means that it has moved to the right. It's a translation. You need to write the word translation. To the right 2 units. Now I want to check my work. I want to see if this works. You can also get extra credit for this. How am I going to check it? I'm going to check it by graphing. So I have Sketchpad open, and I recommend that you keep your Sketchpad program open while you're doing this. And I'm going to go ahead and graph f of x equals parentheses x minus 2 squared. So you go to graph, plot new function, and I need my parentheses. You don't have to type the f of x equals, just the parentheses x minus 2. And then the parentheses do get added. You can just click outside, and then I have to type squared. So this here should look exactly like this here. And then I click OK. And here's my graph. Now let's compare this graph with what I answered. So is the vertex 2, 0? Well, here's my vertex. The vertex is where the parabola begins to change direction. I can put a point there. You see I grabbed it from over here, put it here, and then I can measure that point. I can measure the coordinates. And it's almost exactly at 2. We're going to assume that that's 2. It's slightly off. It opens upward. Yep, got that part right. I have to name 2 other points on the graph. I said that 1, 1 was on the graph. That would be a point right here. That definitely looks like a point. And I also said that negative 1, 9. Well, I can't see negative 1, 9. But I can scroll up, and here would be negative 1, 9 right here. And it does look like that is a point on the graph. Okay, so those are good. And then I had to answer, how has the function been transformed from the parent function? And I said that it was transformed by, it was translated 2 units to the right. Well, you can graph the, let me grab this back. You can graph the, I lost the top part of my graph. Here we go. The parent function on here, which was y equals x squared. And there's the parent function. Does it look like that parent function, or does it, okay, if I start with the parent function, which is the black one that I just graphed, did my function of f of x equals x minus 2 squared move over to the right, translate over to the right 2 units? Well, yeah, it sure does look like it moved over to the right 2 units. So therefore, it looks like I have all the parts of my answer correct for number 3. So you're going to do the same thing on the other problems. And then the next section also includes some reflections, stretches, and compressions. Reflections are easy enough. We're only going to talk about reflections about the x-axis, where the number in the front will be flipped over. The parent function across the y, reflected across the y-axis, you can't even tell anything has happened. So, okay, so we are going to do pretty much the same thing on this section, but there might be some other types of transformations than what we've talked about before. Let's look at number 8. Number 8 says h of x equals 1/2 x squared, or you can use h of x equals 0.5 x squared. You need to identify h and k. It's already in vertex form. And we can see that there is no number being added or subtracted. So that is 0. And there is also no number being added or subtracted from the end. So k is 0. So the vertex is 0, 0. Now, to find out whether it opens upward or downward, you need to look at the a, the number in front of the x. And that is 0.5, and it's positive, so it opens upward. Now, what about the transformation? Because h and k are 0, there has not been a what about the transformation? It's not a translation, it's a transformation. There is no translation because h and k are both 0. However, because there is a number in front of the x squared, that does mean that there has been a stretch or a compression. So let's look up here. If we have our x being multiplied by a fraction, like we have 1/2, then that means that there is a compression toward the x-axis. So there is a horizontal compression towards the x-axis. So we are going to write that there is a compression. Which one was I doing? And the factor is, let's look back at our box. Whoa. Our compression is by a factor of 1 over that number. Horizontal compression by 1/2. Is that all we had to answer? That's all we had to answer. If you have a negative in front of the x squared part, then there is a reflection about the x-axis, as in number 9. This one also has a translation to the right 4 units, because the number that is being subtracted from x is 4. And let's see, so you'll continue working on those. In 11 through 13, you just have to match the correct graph with the correct equation. So we'll call the first graph 11, this one 12, and this one 13. I guess I didn't put numbers on here, but... And then the last section is going to be taking some information about how it has been transformed and using that to write an equation. And we're going to use the A, the H, and the K in order to write our equation. So if we can figure out what those are, all we have to do is plug them into our vertex form. So the parent function f of x equals x squared is vertically stretched. That's our A, by a factor of 2. And it's translated 3 units left, so that means h has to be -3. It doesn't say anything about translating up or down, so then we use k equals 0. Now all you have to do is plug those into this equation, or this form of the function right here, vertex form, and you will have your equation. And do the same thing for number 15. All right, that's it. I hope that helps. If you get stuck on any of these, send me an email and I'll give you some more help, or you can come to my office hours and we can work together. Thank you very much. Have a wonderful day.